The higher the reorder point, the higher the service level. However, using the same reorder point for two different items doesn't necessarily guarantee you the same service level. That's exactly what you can see going on in this scenario. Let's look. Adventure Center workers reorder crushed ice and cubed ice. Okay, that's what I mean by two different items. When their refreshment kiosk has only 15 pounds remaining in stock. Ooh, that is a reorder point. 15 pounds. Okay, crushed ice and cube ice are used at a rate of 5 pounds an hour, but both take 3 hours to deliver to the kiosk requesting more ice. Both are produced by Adventure Center's catering facility, which reliably delivers, now wait a minute, it says delivers the cube ice in 3 hours. The lead time for crushed ice, however, is usually between 2 and 4 hours, but sometimes the crushed ice arrives in only an hour or takes 4 to 5 hours to appear. Even though demand for crushed ice is the same as for cubed ice, workers feel that it is not appropriate to use the same reorder point, because in both cases they're reordering when there's 15 pounds left. Okay, first question. How do the distributions of demand during lead time differ for two items, crushed ice versus cubed ice? Now, this is a pretty short scenario, right? It's just one little paragraph of information. There is an unusually crazy amount of information lurking inside that one paragraph, though. So I'm going to, before we, make some informed comment on their query, I'm going to need to organize this information. They keep saying crushed ice and cubed ice. The easiest thing to do is let's handle cubed ice first, because cubed ice is simpler than crushed ice. I can see that already. The first item that we'll look at is cubed ice. What do they say about cubed ice? Well, they say in the case of both types of ice, they're being used at a rate of 5 pounds an hour. So both types of ice, that includes cubed ice. That is essentially our lowercase d. That is our demand rate, 5 pounds per hour. Yeah, okay. Now, what else? Okay, both take about 3 hours to deliver to the kiosk, but and I had underlined it before, cubed ice, just cubed ice, it says reliably delivers in 3 hours, which means that's exactly what happens. Oh, wait a minute, this issue of the wait until they get more cubed ice is LT, the lead time, and they're saying that the lead time is 3 hours. One thing I want to point out here is there's no questions in either case. This is constant. They're always using up 5 an hour. They always wait 3 hours before they get more. Constant, constant. This is what we call deterministic. Meaning that it is not hard to estimate DDLT, demand during lead time, for cubed ice, because if they always wait exactly 3 hours before they get the ice, and they're always using 5 pounds an hour, 3 times 5 equals, that must be where they got the 15. I circled up at the top that they said that their reorder point was 15. That makes sense. That's where they got the 15 from. They always need 15 pounds of cubed ice every time they wait for a new order. Now, that's cubed ice. That's 15 is perfectly appropriate. There was a hint in this paragraph that the workers aren't totally happy with the 15, but we're talking about not just using that number for the cubed ice, we're also talking about using it for the crushed ice. All right, wait a minute. I need to take similar notes for the crushed ice. First off, demand rate. Well, the demand rate actually is the same. They always use 5 pounds per hour because they said this was true of either kind, right? Crushed ice or cube ice. So that's just the same thing as what I copied above. It's the length of the lead time here that's more detailed. For crushed ice, They're saying the lead time for crushed ice, however, is usually between 2 and 4 hours, but sometimes from 1 hour to 4 to 5 hours. Okay, wait a minute. The lead time varies. So first off, I mean, we're working our way to answering that question right here. First off, I see a major difference here. We had said that the demand during lead time for cubed ice, they're just asking about the distributions of demand during lead time, was deterministic. Here it is probabilistic. Because there's an element of it that's random that you can't rely on just exactly each time. They're saying, you know, it'll usually be between 2 and 4 hours, but sometimes it's as little as an hour, and sometimes it's as much as 5 hours. You say, okay. Now you see 2 formulas that are pre-printed in the note frame. We want to take those comments and we want to roll them up into one definitive statement of demand during lead time for crushed ice. You say, okay, why do I want to do that? Because I've spied to the next page and they're going to be asking for a reorder point, and we're going to need this distribution of demand that is specific to crushed ice. And we can get it with these 2 formulas because we know that this is the constant demand variable lead time case. All right, I'm going to make a sketch. I'm going to make the sketch down here. I'm going to attempt to sketch a normal distribution. It is a cartoon of the distribution of lead time, okay? Where they're saying generally it's 3 hours. Sometime, or it's usually between 2 and 4. And maybe I should have made the tails a little bit longer here on my normal distribution. Sometimes it's as little as 1 or as much as 5. And you say, well, okay. What do we do with that? We need to extract from those comments and the assumption that the true distribution of lead time is essentially normally distributed. That's why I was drawing a bell-shaped curve. We need to then extract from those comments the 2 parameters that definitively name that curve. The first parameter is what is the average demand during lead time? Where is the center of that curve? Oh, and that's not that tough. Because I can see, you know, they had made a statement of around 3 hours. Then they made a statement of usually between 2 and 4. Do you notice how 3 is in the center of that? And then sometimes from 1 to 5, do you notice again 3 is at the center of that? Yes, it's pretty safe to assume that the average length of their lead time, is 3 hours, which means LT equals 3. But since lead time varies, whoops, I need something else. I meant to write a question mark there. I need to know the standard deviation of lead time. Oh, right, and you can see that in the formula here. Not just sigma, but sigma LT. What's the standard? If it varies, how much does it vary? What is the standard deviation in lead time? And they didn't name that. They didn't say that in this scenario. Oh, they believe that the standard deviation of lead time is blah. Okay, but they made some statements that we can, and this is not an exact science, but we can extrapolate logically what that standard deviation must be, because we know where the center of the curve is. And they said that, well, you know, it's usually between 2 and 4. Okay, if you're comfortable with the statement that, let's assume that usually means like about 2/3 of the time, you know, more than half of the time, that means the between 2 and 4 is representing 2 standard deviations to either side of the center, because this is what determines the shape of a bell-shaped curve. Oh, and then the further statement of, well, you know, but sometimes it is as little as 1 hour or as much as 5 hours. then that is suggesting that the 1 and the 5 are 3 standard deviations from the center, because we expect about 2/3 of any normal curve to be within 2 standard deviations of its center, and we expect that almost all of it is going to be within 3 standard deviations of the center. So we've got enough here to pin down a reasonably defensible estimate for, well, what is 1 standard deviation from the center of this curve that describes lead time. Because, and I'm just looking here, if from here to here is 2 standard deviations, I know that measurement because what I happen to be writing on right here is between the 2 and the 3. That means that 2 standard deviations from the center of this curve is 1. Right? Because 2 is 1 away from 3. And the same thing, my sketch isn't exactly symmetrical, but you expect the normal distribution to be symmetrical. This is the center going on the high side. Again, 2 standard deviations would be between 3 and 4, which is a distance of 4 minus 3, 1. Oh, so 2 standard deviations on this curve equals 1. That means that 1 standard deviation must be 1/2, right? For this to all add up. Aha. I now have everything that I need to. Remember I said we were looking for the 2 parameters that define the distribution of demand for crushed ice during lead time. We now have the other one. We have the last one that we need. Now, I've been drawing a normal curve, right? And I've been talking about, okay, this is the standard deviation, and this is the center, this is the mean. You know, and now I'm saying now we have everything we need to determine that. Remember that the curve that I, freehand sketch right there, that's meant to be a vision of the variation in lead time itself. Okay, that's not the same thing exactly as the variation in demand during lead time. And what we really, really want to close out this first part and make an informed commentary about the distribution of demand during lead time for both types of ice is we want to know the parameters associated with demand during lead time for crushed ice. So that is a related but a different normal curve. Distribution of demand during lead time. The center of that curve is determined by this formula. Oh, okay, well the LT is the average demand during lead time, that's 3, right? And then the D is the demand rate, well that's 5, equals 15. Oh, so the average demand during lead time is 15. Okay, the average amount of crushed ice that is needed during lead time is 15 pounds. The same as the exact amount of ice of cubed ice that is needed. Oh, all right. But wait, what's the standard deviation of demand during lead time? Well, we would want to fill out this formula. Right? And we'd say that the standard deviation of demand during lead time is, what's that, 5 times 1/2. That's why we were looking for that number right there. You say, oh, all right, 5 times 1/2 was what, that 2.5? Oh, all right, now I have everything that I need to describe demand during lead time. I can set reorder points, I can determine service levels. First off, I can make a commentary on the service level of their current policy, because their current policy is, it doesn't matter whether it's cubed ice or crushed ice, their current policy is reorder when there's 15 pounds left in stock. See where the 15 is? We discovered it's right at the center of the curve. The service level is the area that's to the left of the center. Well, a normal distribution is symmetrical, so if you are talking about the area to the left of its center, you're talking about 50%. The current service level, oh, by the way, for crushed ice is only 50%. Half the time they don't have enough crushed ice. Half the time they run out of crushed ice before the fresh batch of crushed ice arrives from the central kitchen. No wonder the workers are commenting that they don't think that this policy is wholly appropriate. Anyway, let's close out this first question because it is asking how do the distributions of demand during lead time differ for crushed ice versus cubed ice, and now we have all kinds of data that we can comment on. But let's see, cubed ice is deterministic, whereas crushed ice is probabilistic. While the current reorder point of 15, I'm just writing ROP equals 15, is appropriate for cubed ice, because you always need 15. It has a surface level, right, that right there, of only 50% for crushed ice. Which they're probably not happy with. Oh, okay, yeah, no matter of fact, they must not be happy with, because we're not actually done with this analysis because I have another question. If Adventure Center maintains a 99% service level for the delivery of ice, so that would be either kinds of ice, what should these two reorder points be? Oh, well, again, cubed ice is simple. Cubed ice, keep the reorder point at 15. Okay, cubed ice was fine. You always need 15 pounds during lead time. Keep it at 15. You'll get a 99. You'll actually theoretically get a 100% service level. So you'll certainly get a 99% service level. All right, but the reorder point of 15, as we had just remarked, is only providing a service level of 50% for the crazier crushed ice. So we need to determine another reorder point. Here's our formula for reorder point. Reorder point is average demand during lead time. Now we know that. Actually, for crushed ice, we'll just use this side of the page, crushed ice. For crushed ice, start with the average demand during lead time and add some safety stock, right, in the parentheses. That is to say, some z-value times the standard deviation in demand during lead time, which we worked so hard to find. That's why we needed it. We have it. It's right there, 2.5. So the only thing that we need is that z-value, and then we're done with this question. Okay, that z-value. Let's see. That z-value should cut the curve such that 0.99, 99% of it is to the left at the point that we cut it. And now I'm drawing on a picture of the standard normal curve. Yeah, we're asking the question, there it is, z. What z provides you 99% of the curve to the left of it? Oh, this is using the z-table backwards again. The body of the z-table is all different areas for the rows and the columns are different places you can cut the curve. I just want to look in the body of the table for the one number that most closely resembles 0.9900, and I think I found it. I didn't find 0.9900 exactly, but I found 0.9901. That's close enough. But who does it belong to? Trace the row out. It says 2.3. And then look up. What is this column labeled? We can piece this together. Because on a z-table, the first two digits of that value are here on the row, and the third digit's the column. So this is a Z of 2.33. All right, 2.3, and then the other 3, 2.33. I just need to remember that. That's what I need here. Why? Because if you put 2.33 here, you will be trapping 99% of the curve to the left. Oh, okay. Well, I did that. And I get that that is then 15 plus 5.825. That's your safety stock right in here. But wait a minute, the question was, what's the reorder point? Well, what's that work out to be? 20.825. Ah, all right. For cubed ice, keep it at 15, right? For crushed ice, reorder point should be 20.825 pounds, or considerably higher than the reorder point that they're using now, in order to maintain the exact same service level that you're getting with the cubed ice, a service level of 99%.